Hi, I'm Rhythm. I am going to show you my take on the vectorshift's front-end technical assessment. I'll guide you through each part, sharing both the code and how it works. The front end is built using JavaScript and React, and backend is built using Python with Fast API. The code is available on the GitHub, and the link to the repo is in the readme.md file. Both frontend and backend are deployed on Vercel, and the live links are available in the readme.md file. Let's start with a live demo of the front-end application. As you can see, the styling is done using Tailwind CSS and Shared CN. I used Shared CN along with JavaScript and React as instructed. There are some UI files that are in TypeScript since it's not optional in Shared CN. Here is the text node. Notice how it resizes dynamically as I add more text, just like one on vectorshift's website. This is done using auto-size text area component from ShareCN's expansion library. You can write some normal text, but you can also define variables using double curly brackets within the text, like this. For each variable, a new handle appears on the left side of the node, and the other handles adjust to keep even spacing. I've added a toggle for showing edges in an animated or static way. And there is also a toggle for base edge and one with delete option. Edges are reconnectable by dragging their ends from one handle to another. Also, dropping an edge on blank canvas deletes that edge. I added this for better UI UX even if it wasn't that much required. The toolbar is responsive. On desktop, it's a top toolbar, but on mobile and tablet, it becomes a sidebar, maintaining the same functionality. Here are the nodes available in the sidebar, and here is the submit button to send your graph to the backend. And I have added a user-friendly way to show the response using a modal on the front end, and a little bit of confetti if the graph is both a tag and a pipeline. If not, then you will see an invalid tag for one of them, along with the reason for it being invalid in the same pop-up model. Now let's go to setting up our environment. Let's set up the environment. First, I'll navigate to the front-end directory in my terminal. I will run one install. You can see all the dependencies being installed. Now I'll run one run start to start the front-end application. It should be open in the browser. Next, I'll run the backend directory. So I'll just run uvsync to install the dependencies. Then I'll run uvrun uvcon main colon app dash dash reload to start the backend server. Both the frontend and backend are now running. The package.json file in the frontend lists all the frontend dependencies, and pyproject.toml file in the backend lists all the backend dependencies. Now let's come to the node abstraction. One of the challenges in this project was code duplication. When creating new nodes, to solve this, I created a node abstraction. Here is the code for my abstraction in node-wrapper.jsx. This abstraction allows for reusability and maintainability. I have added this abstraction to create 5 new nodes. I have also added a delete node button to remove the nodes. But the primary function of this node wrapper was to abstract away the complicated logic of writing new handles for the nodes. Now let's come to the styling. For styling, I've used Tailwind CSS and Shared CN as mentioned earlier, and I focused on making the application responsive across all different screen sizes. Here is the tailwind config.js file in the frontend directory. It shows the Tailwind CSS configuration and other CSS variables and overridden classes are mentioned in the index.css file. The main reason for overriding these classes was that the base classes from React Flow's default CSS was clashing with my Tailwind CSS classes, and this was a minor blocker for me. So to solve this, I basically had to go through the installed React Flow package in the node modules to find the CSS file and see which classes were causing conflicts with my Tailwind CSS and needed to be overridden. Next, the text node logic. Now let's look at the updated text node in the text node JSX file. You can see the code that causes the text area to resize dynamically. As mentioned earlier, you can define variables using double curly brackets, and a new handle will appear on the left side of node for each new variable. The variables are parsed and handled within the text node, and handles are rendered using React Flow library. Now let's look at our backend integration. Here is the code for submitting the graph in the submit.jsx file. For sending data to the backend, I mainly used Axios for this, and here's the code for the backend in the main.py file, which contains the /pipeline /parse post endpoint. The backend calculates the number of nodes and edges. It also performs a tag check to ensure that the graph is a valid direct, directed acyclic graph. And it also performs a pipeline check to make sure that the graph is a valid pipeline. The DAG and pipeline check is implemented on the criteria described in the pipeline and DAG validation guide.md. When you click submit on the front end, it will send back the data from this backend and show the alert with the backend response. You can play with the front end to find which graphs are DAG and pipeline and which ones are not, along with the reasons why. In summary, I have demoed the front-end application and node abstraction, styling, and text node logic in the backend integration, including the DAG and pipeline check. Thank you for your time. The code is available for review on the GitHub link that is in the readme.md file.